In this video, I'm going to revisit rational functions 2. We're going to state the domain, range, draw and label the asymptotes on graph paper, and then state the points of symmetry. Now, in this case, we're going to also state the line of symmetry too. So, moving on to our next slide. We have our rational function. We're using a as a number. So we have a over x. This is the parent function, or a very simple one. In this case, the line of symmetry is y equals x and y equals negative x. And this is something that you will have to remember. The origin is also a point of symmetry for this graph, 0, 0. We'll look at why that is on the next example. We have the domain is x does not equal 0, or we could also say that x is all numbers except for 0. And remember, we can't divide by 0, so that's why x can't be 0. And then if you go back and look at our rules for our horizontal asymptote, x is greater than 1 as x gets larger, so our range is y is not equal to 0 since our limit is approaching 0. Looking at 5 over x, what we'll know is our vertical asymptote will be at 0 because 5 will never equal 0, and we know x cannot equal 0. We will also have our horizontal asymptote, as we talked about, at 0, and our limit is going to 0. Our lines of symmetry, and so we'll call that LOS, will equal y equals x and y equals negative x. Our domain, which we'll write with a D, will be x does not equal 0, and our range will be y does not equal 0. Okay, we'll head over to our graph, and we need to graph this. So the first thing I'm going to do this in a different color. Let's do red. My axis, both axes, which is going to be on the 0. And you have to forgive me, I'm not perfect with this. And my y does not equal 0. And so as we graph it, I know that when x is 1, we're going to get 5. So we have 1, 2, 3, 4, 5 here. And then when x is negative 1, we'll get negative 5. So 1, 2, 3, 4, 5. And so I can kind of take a guess of how this would look, just like this. And again, it does not have to be perfect, but we expect to have something like that. Let me go ahead and fix this graph. And so that's how we graph it. Now, if you would like, you can find 2 points on each side. I'm doing this in my head, so I'm only finding 1. And then if we look at this, our axis of symmetry will be the y equals 0 lines. So again, changing colors. We can see here, as my graph, that they fix each other. I know at 5, y should be, when x is 5, y should be 1. So I'm fairly close on that. And then the other lines will be down the x equals negative, y equals negative x. And so that's our 2 lines of symmetry. Looking at our Desmos, a little bit neater than how I drew it, of course. We can look at our y equals x, and clearly you can look folding this point to this point like a sandwich would work, and then also this is mimicking what this does. So those are my 2 points of symmetry. The next example we'll look at is a over x minus h plus k, where a, h, and k are numbers. In this example, our h is going to move our graph left and right, very much like our quadratics, and our k will move it up and down. Our line of symmetry is y equals x minus k plus minus h plus k, and y equals negative x plus h plus k. The points of symmetry for this graph is h and k. This point of symmetry is also where these two lines meet. The domain is x does not equal h, or x is all numbers except for h, and the range is y does not equal k, since our limit is approaching k. Looking at this example, we have 5 over x minus 1 plus 2, and so our first thing will be to find our vertical asymptote, which will be at 1. Our horizontal asymptote is 0 plus 2, so that's 2. Our domain is x does not equal 1, because we can't divide by 0, and our range is our y does not equal 2. On lines of symmetry will be y equals x minus 1 plus 2, which will be y equals x plus 1. And the other one is y equals x plus 1 plus 2, or y equals x plus 3. So our points of symmetry, or POS, will be 1, 2. Now note that we have negative h here. So negative of negative 1 is a positive 1. And looking at our graph, our vertical asymptote will be at 1, where our horizontal asymptote is at 2. And looking at our points, we see that if we plug in 6, we'll get 3. So when x is 6, we'll get our point at 3. If x is 2, we'll get 7. And again, I'm just plugging in these numbers. And so our graph will look something like this. Okay. And then if we go to the opposite side, if we plug in negative 4, we'll get a positive 1. So 0, 1, 2, 3, 4. And so it looks something like this. Okay. Now, again, the graph is not perfect, but we can see that they match each other. Okay. Now, notice that our asymptote is at 1, 2, which is our line of symmetry. Okay. And so, I'm sorry, it's our point of symmetry. Our line of symmetry is y plus 1, which will look like this. And our other one is negative x plus 3, which is going to look something like this. And so the point of symmetry is where my axes meet up and the lines of symmetry. So for the last time, we'll come to Desmos. We have this graph right here, and that's the one that we just looked at, and my drawing is not too far off. When we have these two lines, we notice that they cross at 1, 2, and our axis of symmetry would go, our horizontal asymptote will go to 2, and our vertical would be 1, which again is my x and y values.